All right, let's dive right in. For the longest time, black holes were, well, they were basically just a crazy idea, a mathematical quirk you'd find in the margins of a physics textbook. But then, something absolutely incredible happened. In just the last decade, we've gone from hunting these invisible monsters in the dark to actually photographing them. So how in the world did we pull that off? That's the story we're going to get into.
It really all boils down to one simple, kind of terrifying question. What happens when gravity just wins? When you cram so much stuff into a space so unbelievably small that its pull becomes unstoppable, so strong that nothing, not a spaceship, not a planet, not even light itself, can get away.
And here's the thing that might surprise you. This whole idea, it didn't start with Einstein, not even close. Nope. The concept of an object so dense that its own light couldn't escape, that's an idea that's been kicking around for a really, really long time. I mean, this idea has been building steam for centuries. Way back in 1784, a guy named John Michell was already thinking about these dark stars. But, it was just an idea. It wasn't until Einstein came along in 1915 with general relativity that we got the actual physics, the rulebook for how gravity works. And get this, just a few months later, Carl Schwarzschild uses those brand new equations to describe this sphere of no return. For a while, people thought, okay, maybe it's just a weird math thing. But then, in 1965, Roger Penrose proved that no, these things have to form. They're an unavoidable consequence of gravity. And that sphere of no return, that leads us to maybe the most important concept of all, the event horizon. Now, this isn't a surface. It's not something you could land on. Think of it more like the edge of a waterfall in the river of space-time. Once you drift over that edge, that's it. Every possible path, every direction you could possibly go now leads to one place, the center. There is literally no turning back. Okay, so this creates a pretty massive problem for astronomers, right? I mean, how on earth are you supposed to find something that is, by its very nature, perfectly black and totally invisible? It's like trying to find a shadow in a pitch-black room. It takes some serious cosmic detective work. So, the cosmic detectives got to work, and they found that their invisible monsters come in two main flavors. First, you've got your stellar mass black holes. These are the leftovers from when a truly massive star dies. Think something like 10, maybe 20 times the mass of our sun. And then you have the other kind, the supermassive black holes. These are the absolute titans, the monsters that lurk at the heart of pretty much every big galaxy, including our own. We're talking millions or even billions of times the mass of the sun. It's just a completely different scale. So how do you catch the smaller ones? Well, it's basically a process of elimination. Imagine you see a star out there and it's wobbling. It looks like it's dancing with a partner, but you can't see the partner. So you watch that wobble, you measure its speed and its timing, and from that you can figure out exactly how heavy that invisible partner must be. And here's the kicker. If that unseen object weighs more than about 3 times our sun, well, it can't be a neutron star. So what's left? What's the only thing that fits the evidence? It's gotta be a black hole. Now for these supermassive ones, we can do something that is frankly mind-blowing. We can literally watch individual stars as they whip around the very center of our galaxy at insane speeds. After decades of observation, by tracking those orbits, astronomers calculated the mass of the object they're all circling. That's how we know our galaxy's black hole, Sagittarius A star, weighs in at a staggering 4.3 million times the mass of our sun. So, for a long, long time, that was the game. Find black holes by watching the gravitational chaos they cause around them. But then, in 2015, everything changed. It was a total paradigm shift. We figured out we had a new sense. We learned how to stop looking for black holes and start listening for them. Not with our ears, but listening for the actual vibrations of space-time itself. On September 14, 2015, these incredibly sensitive instruments at the LIGO Observatory picked up a tiny chirp, a signal that had been traveling across the universe for 1.3 billion years. And what was it? It was the sound of 2 black holes, each about 30 times the mass of our sun, spiraling into each other and violently merging. This event sent out huge waves in the fabric of spacetime, the very same gravitational waves that Einstein predicted 100 years ago. But the most amazing part of that signal, the real smoking gun, comes right at the very end. It's a phase called the ring down. See, when you strike a bell, it rings and wobbles until it settles down. That's exactly what a newly formed black hole does. It shakes and vibrates, getting rid of imperfections by sending out more gravitational waves. The specific notes in that ring down are a perfect fingerprint of a black hole. And when they checked the data, it was a perfect match to Einstein's theory.
So, okay, we had indirectly seen their effects. We had now directly heard them being born. There was only one thing left to do, the final frontier, the holy grail of black hole science, to actually take a picture of one, to see the shadow of the event horizon with our own eyes.
Now, this was not easy. This was one of the most incredible feats of engineering humanity has ever pulled off. It's called the Event Horizon Telescope, and it's not one telescope, it's a network of them all over the planet, all working together to create a virtual telescope the size of Earth. The level of detail they can see it's just insane, 1,000 times sharper than Hubble. Yeah, it's literally like being able to take a clear picture of a tennis ball sitting on the moon. It's that powerful.
And after years of work, in 2019, they did it. They released this image. This is the supermassive black hole at the heart of the M87 galaxy. For the very first time in history, we were seeing the unseeable. You can see it right there, this bright, fiery ring of superheated gas swirling around a perfect central abyss of pure darkness.
And they didn't stop there. In 2022, the team did it again. This time, they pointed their Earth-sized telescope at the black hole in our own galaxy center. This one was way harder to photograph because all that gas is whipping around it thousands of times faster. It's like trying to take a clear picture of a blurry firefly. But they pulled it off, and the result confirmed what they saw before, that same ghostly ring of light surrounding a central void.
So let's be really clear about what we're seeing in these pictures. That dark spot in the middle, that's what we call the black hole's shadow. It's the silhouette of the event horizon, the area where if light goes in, it never comes out. And that glowing ring, that's light from all the hot gas behind and around the black hole, getting bent and twisted by that extreme gravity like a cosmic funhouse mirror before it finally reaches us. All right, so we've gone from a wild idea 200 years ago to decades of detective work to literally hearing them collide, and now, finally, to seeing them. So what's the bottom line? What does all of this mean?
Well, first and foremost, it means black holes aren't just theory anymore. They are real, and they are everywhere. It also proves that Einstein's theory of general relativity is right, even in the most insane gravity-warped environments you can imagine. We now have visual proof that event horizons, these one-way doors in space-time, actually exist. We've really gone from just inferring these things exist to observing them directly. It's a whole new chapter for astronomy.
Think about what's been accomplished. We have taken a photograph of the edge of an abyss. We've seen the boundary line, the point of no return, where our current understanding of physics starts to get fuzzy. And that leaves us with the biggest question of all. We've seen the doorstep, we've photographed the edge, but what secrets are still hiding just beyond it, forever locked away behind that horizon?